So in the last video we have talked about some check, okay, that we need to actually have a check before reporting our answer. So let's see that if we have, we need to find the LCM of, let's say, three rational number of the form a by b, then c by d and e by f. Okay, so we already know that this is equal to LCM of the numerator, which is a comma c comma e, upon HCF of the denominator, which is b comma d comma f. This is known to us, okay, from our basic mathematical knowledge. We know this. Now it's very important to know some more the periodicity of some more functional form like if we have sine nx cos nx, okay, and they are reciprocal, that will be cosec and sec respectively. So it is cosec nx and this is sec nx, okay. So their periodicity is basically depending on the value of n. If n is odd, the value is 2 pi, and it is pi if n is even. And the other two, which is tan nx and let's say it is cot nx, so this value is as it is for pi. And one more thing, if we have the function in the modulus form, that is mod sin x mod cos x, so we can note it down as well, that is mod sin x mod cos x, and all the functions, all trigonometric functions in the modulus form, their period is pi for all the trigonometric functions. Now we were talking about a check in the sense that if, let us say, we have an example that we have to find out the period of fx as equal to sine to the power 4x plus cos to the power 4x. So this is the function and we have to find out the period of this function. Now if we go by the earlier logic, that is the value of the individual period of cos 4x would be, that is when n is even, so it will be pi, and cos 4x is also pi. So by that logic, LCM of pi and pi would have been pi, but the answer is not pi. That means we have to make a check, and the check is whenever we have trigonometric functions and we don't actually follow LCM of the individual individual period, we always make a check, especially when we have the combination of sine and cos. We may not do it in the case for sine and tan or any other combination, but we always make a check when we have the linear combinations of sine and cos. So what the check is, we will also check at the period at t by 2. Okay, we will also check at t by 2, which means t is we are having t as pi. Okay, t means the overall period. So we are getting pi, right? This is the overall period, we are getting pi. So also check at pi by 2. I mean to say, also check at pi by 2. So if we check at pi by 2, so let's see here. This is going to become sine 4. This is x plus pi by 2, and this one as cos 4 x plus pi by 2. So we know that sine pi by 2 plus x, and it is in the even power, so this will become cos 4, it is x plus sine 4x, and that is equal to fx, right? And here our period comes out to be as pi by 2, not pi. So pi by 2 is the correct answer. So this is an important check while solving the problems in which there is a linear combination of sine and cos. Okay, now one more thing, what about constant functions? Are they periodic? Constant functions. So the answer to this question is constant functions are also periodic. If I am having, let's say I am having in the form of sine square x plus cos square x, if we have this function, and we know that this is basically a trigonometric identity and this value comes out to be 1. So is it periodic? Answer is yes, it is also periodic, but there is no fundamental period. No fundamental period. No fundamental period. So all constant functions are also periodic, but they don't have any fundamental period. But in this scenario, in this particular investigations, we always find the fundamental period. Okay, so this is just an important check that you are going to make. Although you know the answer, directly by solving LCM, but do a check at t by 2. That means the value that you are obtaining upon 2, you just have a check, and it may happen the answer is coming differently. It may also happen that it may come as pi itself. Let's take up another example in which even if we check, we are getting the same answer as with the LCM case. So let's say that we have function fx equal to sine 2x plus cos x. So the period of sine 2x is 2 pi by 2 and its period is 2 pi. So we basically need to investigate or find the LCM of it is pi and 2 pi. That's equal to 2 pi. Okay. Now have a check at pi. Have a check at pi. So if we check at pi, so it will be sine 2x plus pi plus cos it is pi plus x. So this will become actually minus sign. So that means the period is 2 pi is correct. Okay. So that's all for this video, and we have actually understood this periodicity, and it is a prerequisite to solve the problems of the turning moment diagram. Okay. Thank you.